Hello, today we're going to be talking about unlocking the Victorian 2.0 curriculum and getting insightful with algorithmic thinking. Hi, I'm Kathy, and I'm the content lead for Junior Math, and I'll be joined later today by two of my colleagues, Anthony and Toby. All right, so what are we going to cover today? We'll be covering the review of changes to the Victorian 2.0 math curriculum. Then we'll be doing a deep dive into algorithmic thinking, and we will be looking at lesson insights, which is a new feature of our Edrollo platform. Okay, so by now you've probably seen all of the changes in the 2.0 math curriculum. So we'll go over some of the key changes in each year level. In year 7, one of the major changes is now we are adding circles to year 7. So we'll be talking about circumference and pi, and also adding in the volume of triangular prisms and not just regular prisms. In space, we have added algorithmic thinking to space, where they will be looking at algorithms to sort and classify shapes, and they remove the previous dot point of using a simple general purpose programming language. Statistics, they're using now more investigations and real life examples and talking about continuous and discrete data. And also in probability, incorporating more chance experiments, talking about predicted versus observed results and effect of sample size on outcomes. In year 8, we'll see an addition of more financial context, specifically around profit and loss. Also moving Pythagoras from year 9 more into year 8. So in our Edrollo resource, we did have in our year 8 resource last year an introduction to Pythagoras theorem. So it's nice to see that now in the curriculum, they've also moved Pythagoras from year 9 to year 8, providing more of a foundation for the kids and scaffolding that learning before they get to year 9. Another main change in year 8 is talking about 3D coordinates on the Cartesian coordinate system. So moving from just X and Y coordinates to X, Y, and Z. This is a pretty big change for year 8 kids. In algorithms, we also see where they'll be using algorithmic thinking to identify congruence and similarity and reason how these algorithms will work. Again, we see here in statistics and probability of using more real-world investigations and experiments using digital tools. In year 9, we see algorithms come up again. So now they're designing, testing, and refining and scaffolding the algorithmic learning. So being able to explain how they work and embedding the vocabulary. In statistics, we see another investigation of using statistical context and how sampling affects the data. I think we saw this and the importance of this during COVID, where it's really important in using the correct sampling methods and also choosing appropriate forms of display, visual display of the data. In probability, using digital tools, again, discussing the probability of compound events. In algebra, we see the expansion and factorizing of quadratic equations, as well as the parameters of functions and more financial context involving simple interest. So in year 10, there are more changes, some movement from 10A now into 10 core. One of the big changes in measurement is introducing logarithmic scales to logarithms. There's also problem solving with modeling and a focus on measurement errors, accumulated errors, and accuracy. We see this well in number, where there is a focus on rounding errors and approximations of repeated calculations. This was a big focus last year in VCE in the general exam. In algebra, algorithms has been moved here, where algorithms is using data structures and introducing pseudocode. And moved from 10A to the core are quadratic, reciprocal, circle, and exponential graphs. Another change in year 10 is introducing networks in space. This was also moved from General 1-2, so it's good to be able to give the kids this exposure to provide the foundation in year 10 before they go to senior math. And in probability, discussing the errors that can occur in language with conditional probability. So focusing again on the language and the vocabulary if-then statements. In statistics, they removed a previous dot point to combine bivariate data and time series data into a more refined dot point now in STO5. And finally, in 10A, there are some new introductions of fractional exponents in surds and number. There's a focus on functions and also the inverse relationship between exponential functions and logarithmic functions in algebra. In measurement, there's the introductions of rates of change and limiting values, providing that exposure of sort of a pre-calculus exposure before they get into calculus and methods in senior. Also looking at volume of pyramids, cones, and spheres. In space, we see from moving from measurement in the previous Victoria 1.0 curriculum, circle theorems, tangents, chords, those are all moved now into space. And algorithms, again, they'll be looking at designing, testing, and refining algorithms in spatial problems. In statistics, there's been a move now to analyze the data and also a focus on commenting on the data. So on trends and behavior and being able to comment on their interpretations. In probability, we see an introduction in factorial notation and counting principles, and so where we'll see permutations, selections, and arrangements. So from what we've just summed up there, as you notice, there is the major change is a more refined and defined trend in the sequencing of algorithmic thinking from 7 to 10 in a more deliberate and scaffolded progression. Here to talk more about how we articulated this new major area into our resource is he's not only an experienced science, math, and infotech classroom teacher, but he has also authored our senior physics resources as well as junior science.
Hi, I'm Anthony. The question many of you might be asking is, what is algorithmic thinking? Well, algorithmic thinking is a process or steps used to solve a problem or do calculations. It's been added to the curriculum from 7 to 12, as you heard Kathy talk about, and it's important that we understand this isn't just something we have to teach because it's in the curriculum. This is an important skill that all our students need to know to get jobs in the future. Many of you will know that programming and understanding of spreadsheets and digital literacy is something that is used in almost every job today, and that's only going to increase as we move ahead. So, as you can see, an example in Year 7, a couple of curriculum dot points, and the Year 12 curriculum dot points are taken from the methods, VCE methods curriculum, study design. So to cut a long story short, we need to teach algorithmic thinking, but you don't need to worry because Edrolo has you covered. In Year 7, we introduce algorithmic thinking in the form of flowcharts. And in Year 12, they need to be able to understand pseudocode. What is pseudocode? Pseudocode is an informal way of understanding a program or writing a program. It's not specific to a computer programming language, but it's the background, the understanding maths behind programming that we're teaching. So how are we going to do this? Well, from Year 7, we need to take them from flowcharts, and we need to scaffold that all the way up to Year 12 so they can understand and write pseudocode. Instead of just tagging on a paragraph or an example at the end of each lesson, we've decided this is important enough that we're going to write 2 to 3 lessons in each year level about algorithmic thinking so that students understand it and teachers can teach it easily. So these lessons are going to be full lessons, including everything you love about our maths product. So there's going to be learning intentions, key ideas, worked examples, fluency, problem-solving questions, reasoning and exam questions, and chapter reviews to make sure that students and teachers understand algorithms and can implement them. We're also going to include digital tools in this. So they're going to learn about algorithmic thinking, and then we're also going to help you and help students improve their digital literacy by allowing them to apply their algorithmic thinking to the maths they've learned in that year level in a deep and meaningful way. So we've got spreadsheets, which we start off with, and we also do that using Desmos. So we got extended applications, which the students can take their algorithmic thinking they've learned that year level and then apply it through Desmos and spreadsheets to the other maths they've learned in that year level, improving their digital literacy and improving their core maths and algorithmic thinking. Finally, We've also got chapter reviews and everything that you are used to using in your 7 to 10 maths product. So, Enroller has you covered 2 to 3 full lessons each year level that includes everything you're used to, extended applications, and the incorporation of digital tools in the form of Desmos and spreadsheets so that your students are ready to use their graphing calculators when they reach VCE math. Finally, what do you need to know to teach this to your students? Nothing. You don't need to stress because we've got you covered. We've created a series of lessons that scaffolds algorithmic thinking all the way from year 7 to year 10, which makes life easier for your students and for you. So, these are full lessons with all the enroller pieces you love, so you don't need to worry. We've got you covered.
Hi everyone, I'm Tobi. I'm the lead product manager at Enrollo, and today I'm super excited to introduce you to our next teacher sidekick, Insights. As all sidekicks, it is there to support you, because at Enrollo we really believe that teachers are the people that can have the biggest impact on student success. So we build Insights in collaborations with teachers across Australia to help them enhance their teaching and learning effectiveness. As a result, what they're telling us is that they're feeling better equipped to identify and tackle learning hurdles, foster greater engagement in the classroom, and also tailor their teaching to the class needs or even to specific individuals' needs. So we all know teaching is stressful. There's like student reporting, it's the endless staff meetings, parent calls, behavior management, all while also being expected to be an excellent classroom teacher. You want to be able to make sure you're catering to all your students' differentiated needs, spending time with them one-on-one, and also making sure that no one is left behind. It's stressful. It's like playing catch-up, or worst of all, might leave you feeling a little bit inadequate. But with Insights, you're going to be able to answer the 3 most common questions on the spot. Is my class ready to move on? Are my students engaging with the work, or is there anyone that needs a nudge or anyone who seems stuck? And who needs support the most, and with what? The reason for these 3 questions is to give you the quickest teaching feedback loop, allowing students time to practice and revise, help students take ownership of their learning. It aids you as a teacher in improving and refining your instructional strategies. And most of all, we've also heard from teachers telling us that they now found the classroom being more collaborative and more engaging. So let's dig in and have a look. So let's have a look at Insights. All Enroller lessons comes with a comprehensive set of practice questions. So you'll find them here. It will say questions. So by giving your students time to practice, either in the classroom or as homework, you will see Insights start coming into you immediately. You can identify that you have Insights available over here on the right hand in this green circle, which is indicating how many questions students have responded to across the class. So let's click into Insights. As mentioned, Insights is there to be the quickest teaching feedback loop, answering the 3 questions that we outlined. So is my class ready to progress? Are my students engaging, and who needs my help? So let's go through them one by one. So to learn if your class is ready to progress, one of the most important things is to understand if there are any common misconceptions that you need to recover or reteach before moving on. So the first 2 tables here will tell you what the questions are that stump most of your students. In the first table, we can have a look through and see what are the things we're seeing here. We have question number 12, where 10 students have responded to it and everyone got it incorrect. Because this is a problem-solving question, we know we want to teach students about literacy and being good at solving worded problems, and it's also a mild question. We might want to have an extra look at what we can see what the misconceptions are. So let's click into this question and see what possible misconceptions there might be. On this page, you'll be able to see all the information about the students' individual responses. First of all, we might want to refresh our mind and see what was the actual questions that the students were responding to. In this case, it's how long are each of Carlos' steps if he took 12 equal steps and crossed his 15-meter front garden? Give your answer in the simplest form. And we can look quickly here. We also have the correct response, which in this case is 5/4. Now we can go back and look at the student responses. To make it a little bit easier to review, we're going to sort the student responses, and we can do that either by clicking student responses or answered correctly. In this case, we'll click twice on answer correctly to get the ones that didn't answer correct. And we can then go through and look at the student responses and see what are the most common mistakes that were made. And we can see here that there's a big array. Some of them have changed the numerator and the denominators. Others have not put it in the simplest form. And some of them have put it in decimal form even. So with this knowledge, you're now able to adapt your teaching strategies and decide what you want to go back and perhaps cover again with the class before moving on to the next topic. Let's move on to the second question, and that's the one whether are my students engaging? So if we scroll down, we have the table called Student Engagement and Understanding. In the first column, we have questions completed. So very straightforward, we can sort this column to see who are the students that have answered the most questions. To reassure you about this as well, if you go all the way to the top, you can see up here, when was it that the insights was last updated. So we can see here it was updated 0 minutes ago. So if I'm doing this in the classroom, I can quickly go down and see who has completed how many questions. And finally, we want to understand who are the students that need our help the most. There are two things in this table that will help us identify this. The first one is we have a number of marks that the students got on the questions, and the second one are where the students have marked themselves as needing help. Because every question comes with a self-reflection, and we really want to encourage students to be honest here. It's a tool for you as a teacher to be able to help the students without the students having to announce to the class that they need help. We can see here, and this is not something that is completely uncommon, but we see that no students have actually raised their hand in this case, saying that they need help. So what we'll do instead is we'll look at the number of marks. We'll click twice just to sort them. Now we're not going to worry about the students with a mark above 60%. So we'll scroll down and have a look at the students that are below 60%. We look at Guinea Buffalo. Guinea Buffalo has answered 57 questions. She's got 20 out of 57 marks, but she hasn't said that she needs help with anything. So she feels like she understands everything. Let's click in and have a deeper look at what Guinea Buffalo has done. So when you click into this, you get this grid with all the student responses. There's a legend at the top to help you understand as well, because this is showing you a lot of information. The background color is showing you the student self-reflection. Then we're looking for the little green icons or the red icons in the corner to indicate whether the student got the question right or wrong. So what we'll do is we'll find Guinea Buffalo. We have Guinea Buffalo, and we can see she's done the 57 questions. If we then scroll across, we can see the understanding worksheet was okay, and then she goes into the fluency questions, and we can see that at the beginning of the fluency section, she's doing really well. Then we get up to 5A, and this is where it gets a little bit more challenging for Guinea. We can also see if we scroll over to the right, that she also struggled with the spot the mistake questions. We can also go into another question. In this case, we'll have a look at question 7A. So we can see Guinea answered 1 1/4. I want to see what was the question she struggled with. Convert the following fraction into an equivalent fraction with a denominator of 48. So if we go back, we could see that Guinea seems to struggle a bit with converting fractions in different ways. So that way we know that maybe I want to spend a little bit of extra time with Guinea. And that is Insights. So to summarize, what is Insights? Insights is the quickest teaching feedback loop to help you make your teaching and learning more effective in the classroom by answering the 3 most common questions. Is my class ready to move on, or are there any important misconceptions that I need to address first? Are my students engaging? And who needs my support the most and with what? Thank you.